Hello, this is Dr. Mears, and today we are going to be learning about sigma notation in year 1 of Applications and Interpretations. So sigma notation has the Greek letter sigma and is often used to represent a sum of values. And so we see the sigma here. So sigma means add them all up. So that's what sum is, add. So we have S sub n. This S represents the sum of some series or some series of values. Now we have sigma I equals 1 to n. The I is where you start. So wherever that number is, that's your starting value. The n is your end. Get it? End. Your end value. This is going to be the formula that you use, or the form, the general form or formula. And these are your expanded values. After you have your expanded values, you would add them all up. So let's see what I mean here. Okay, number 1 in our examples. Write the expression sigma, where I equals 1 to 4 of 2i as a sum of terms. So what they want us to do is they want us to start at I equals 1. And then they want us to go to I equals 2, I equals 3, I equals 4. So we're going to go from 1 to 4 consecutively. We're not going to skip any numbers. We're just going to 1 to 4. Just increase 1 to 4. Now, what we're going to do is we're going to use this little expression that they gave you. I like that expression that they gave us. And we are going to substitute in where the I is the number that they gave us. So this would be 2 times 1. And 2 times 2i, remember, is 2 times I. So it's going to be 2 times 1, which is 2. Here, 2i, it would be 2 times 2. 2 times 2 is 4. Okay, we have 2i. We now have to substitute in 3. So 2 times 3. 2 times 3 is 6. Okay, we have our expression 2i. 2 times, now we have to do 4, which is our end value. Up here, that's where we stop. 2 times 4 is 8. Now, let's write this professionally. We have sigma I equals 1 to 4 of 2i equals, let's put these numbers in, 2 plus 4 plus 6 plus 8. And that's how to write the expression as a sum of terms. Now, part B, let's actually calculate. So what do? We add these numbers up. We add 2 plus 4 plus 6 plus 8. So let's do that. 2 plus 4 plus 6 plus 8 is 20. So from I equals 1 to 4 of 2i equals 20. So when you add all of these numbers up, you're going to get 20. And this is, let me push the paper down. And this is how you write the sum of the terms. Add them up. That's how you write it. Okay, let's go to the next sheet. Let's more practice. Okay. Part A, write the expression sigma I equals 2 to 5 of 2i plus 3. Or we could say the sum from I equals 2 to 5 of 2i plus 3 as a sum of its terms. So where are we going to start? We start at the I, so we start at 2. I equals 2. Okay, I equals 3. I equals 4. I equals 5. I stop here. Start, stop. Okay, here's our expression, 2i plus 3. 2i plus 3. So where the I is, you're going to replace it. You're going to replace it with the value they had you start with, 2 times 2 plus 3. So instead of I, I'm just rewriting the 2. Now, we could do this in the calculator. 2 times 2 plus 3, 7. Or if you knew to multiply and then add, you could use order of operations. Either one works. So 7. Okay, 2i plus 3. So now we have to put in the 3. 2 times 3 plus 3. 2 times 3 plus 3. 9. Okay, 2i plus 3. Now we have to replace the I with 4 plus 3. 11. You see the pattern. 2i plus 3. 2 times 5 plus 3. 13. Let's write it as a sum. Sigma. You'll get used to writing that little sigma. From 2 to 5 of 2i plus 3 equals 7 plus 9 plus 11 plus 13. Part B, calculate the sum of the terms. So we're going to be adding them up. I'm just going to rewrite this first. Now let's add all of these up. Clear? 7 plus 9 plus 11 plus 13. We get 40. 7, 9, 11, 13. 40. So we add those up. We got 40, and this is how to correctly write it. Okay, and our last example. Write the series 1, 3, 5, 7, 9, 11 using sigma notation. Okay, so we have to figure out where we start, where we stop, and what our expression is in the middle. So here's the tough part, because we have to now play around with some numbers. So we have to say, okay, we're going to have to do something to get from 1 to 3. Now I know you guys are thinking, oh, you add 2. So this is plus 2 plus 2. But I don't think that we could do I plus 2. Because even if we started at, let's say 0, 0 plus 2 is 2. We don't get here. We don't get to there. We wouldn't get to 1. So this wouldn't work. I'm going to tell you a secret, as you might see this a lot. These are all odd numbers. There's an actual formula for odd numbers. And the formula is, if you multiply any number by 2, so any number I by 2, and you subtract 1, you will get an odd number. That's the formula. You double it, multiply it by 2, and then you take away 1, and you will always get an odd number. So what could I start with? So if I was 1, let's see what happens. Okay, so let's say that I was 1. I'm just replacing it with the number 1. I'm wondering if this is where we start. So 2 times 1 is 2 minus 1. What's 2 minus 1? 1. Oh, look, that's where we started here. That's where we start here. Ooh, perfect. So I equals 1. This is 2i minus 1. This is going to help you. So if we have even numbers, it might just be 2i. Odd numbers, 2i minus 1. Now that you know that little trick. Okay, where do we end? Well, this was 1. I bet you that's 2, and we can check it. 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. 3, okay. So we start at 1, 2, 3, 4, 5. This would be the 6. So we're going to stop at 6. So it's as if when I equals 1, we got an answer of 1. When I equals 2, we got an answer of 3. When I equals, I don't like that plus sign, 3, we'll get an answer of 5. When I equals 4, we'll get an answer of 7. When I equals 5, we'll get an answer of 9. And when I equals 6, we'll get an answer of 11. Just like what we did up here. So I had to find where we started, 1, we put 1 into the formula, we'll get 1. And where we end, 6, we put 6 in the formula. 6 times 2, there's my lights, is 12. Minus 1 is 11. So take this, knowing this was the odd formula, the odd number formula that you now know, this could be definitely helpful in your studies and for predicting patterns that we're not used to. So we were doing arithmetic patterns like this. Now we actually have a little bit of multiplication and subtraction. We're going to get into how to find patterns that aren't just as simple as adding or subtracting, that do have some multiplication in it, but that is going to be for another day. So I really wanted you to understand how we expand out by substituting the numbers in, where we start, where we stop, and then what to do with the numbers to add them up. This was a little extension showing you what's going to be coming up. All right, this has been Sigma Notation. I hope it helped.